Hello, everyone. Thank you for joining us for the next session of our Azure Decoded series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our experts to answer. Our session is being recorded. It will be available to view right here on the Reactor channel. With that, I'd love to turn it over to our presenters for today. Thank you both so much for joining.
Hi, everyone.
Hello there, everybody. Thank you so much for having us. I am super excited to be here and joined by Lee Stott today. I am also very happy to be back with our Azure Decoded series. So today's episode is going to be about multi-agent orchestration on Azure. Really trying to get into the weeds and give an overview of what happens when agents work together. This is going to be the series that we're doing around Azure Decoded that covers a couple different topic areas from AI, apps, agents, developers, and all the way through Fabric data and migration and modernization as well. Before we jump into everything today, though, would love to pass it to you, Lee, just to give a little bit more info and overview about yourself.
Yeah, thanks, Aaron. So hi, everyone. I'm Lee Stott. I'm a principal cloud advocate in our developer relations team in Core AI. So I primarily work around Microsoft Foundry and our models, agents, and observability. So really looking forward today to talk about Microsoft Agent Framework. So yeah, really excited by this.
Me as well. And like Lee mentioned, I wanted to kind of just give like a little bit of an overview and recap, because I know that we talked about some of these in the previous Azure Decoded episodes and series, but we had covered the different challenges that exist for developers when they're building agents, or as we think about this agentic shift within the software development lifecycle. We had covered Microsoft Agent Framework with Spencer. We talked about where do we start to build an agent, how do we connect to different other services. But like I mentioned, I really want to dive deeper into some of the ideas around how do they work together, observability and understanding what they're doing, and then also how do you manage and deploy some of these different assets as well. On the other side of this as well, we're going to have basically, oh, my bad. One
skipping way too ahead, getting too excited.
There's too many good stuff on here. On the other side of this as well, we're going to have a couple of different solutions that fall into this for different agents. That would cover, like I mentioned, the Microsoft Agent Framework, MCP, A2A, agent to agent, multi-agent frameworks, and again, that overview for different telemetry, and Purview, and then our hosted agents in AGUI. Before I move into Microsoft Agent Service, Foundry Agent Service and Microsoft Agent Framework, anything that you want to add on like this general overview, Lee, and kind of your own experience with agents?
Yes, I think, what we're trying to set really is there's so many different options for you as developers to, number one, build an agent solution, and then also host that agent solution. So hopefully what we want to try and go over today is primarily using the Microsoft Foundry toolsets. So we're specifically going to be looking at the Microsoft Agent Service, Microsoft Agent Framework Service, which is the orchestrator to wrap those agents. We're going to keep this fairly high level. We've only got an hour. There's other amazing sessions that are also going on that go into much more depth. So like Pamela Fox's agent series. And again, we'll link to those resources at the end. But what we want to do today is sort of give you that high level view of where the technology is. And then also give you some demos. So I've got a few good demos to show you of how agents work and how multi-agent orchestration works. Talk about the patterns and the processes of those agents, and then look at some of these fundamental issues. So I think what we're trying to do here at the beginning is like there's lots of choices. We want to try and give you the easiest way to go to market with agents.
Absolutely. Couldn't have said it better myself. So moving forward, I want to start with this slide before we kind of get into the more common agentic patterns, which Lee, I can let you talk to a little bit as well. But really, this slide covers the end-to-end platform for building agents. Like Lee mentioned, we're going to be focusing on the Foundry agent service, the Microsoft agent framework for the way that we think about building scalable, production-ready agents. And for all of this, developers, they have to start with declarative or single prompt agents. You start not at the bottom, but you start with less complex agents. And then as the work gets more complex, or as you want to add more tools or different layers of intelligence, orchestration, security with your agents, then your multi-agent workflow begins to evolve. And you can use consistent agent-first SDKs, APIs, and the proper UIs. But really, at its core, Foundry as a platform provides all the different models that exist. Let me be mindful there. We recently made sure that we are offering all the kinds of models from Claude and obviously OpenAI, as well as a slew of open source models that also exists on Foundry.
So over 11,000 models, Aaron. Come on, there's too much model choice. And I think that's one of the key questions is like, what model do you use? So yeah.
And like Lee mentioned, with the amount of new models that are coming out, I think Quinn 3.5 also just came out this past week. Like, there's so much choice out there when we're thinking about models, tools, memory, and conversation as different managed capabilities. Lee, how do you approach some of the, I feel like sometimes developers can feel overwhelmed by everything that's available to them.
Yeah, definitely. Yeah. So I think, the key thing is, what we're trying to really, I'll put two hats on here. So, I'm an academic at University College London, so I'm a professor there, and I'm also work at Microsoft. And I think a lot of the area now is about change. We're in a rapid era of change. This slide is new. There's lots of new technologies and lots of new logos on there. So number one is evaluation-led development. Always start with an intent in mind of what you want to develop or what you want to deliver, and then have a set of business KPIs, technical KPIs to evaluate, is my choice correct? So first of all, you always start with the model. Am I using the right model? What are the benchmarks? What are the outcomes of that model? Am I evaluating the model from a human perspective of running one model against another model in the playground to see what the responses are? Am I using benchmark tools to then benchmark those models to see, is this the right type of model? Then we build our agent service. So again, we evaluate which agent framework do we use? How do we orchestrate those agents? And then we're really now into this era of spec-driven development. So once we start to develop these agents, what are the specifications of those agents? Are we just going to vibe code it and hope it goes well? Or are we going to build very good specifications and guide rails around those agents to make sure we build them correctly and be able to monitor them effectively? So that whole observability piece. And then also, what tool sets are we using? So there's great tool sets like AI Toolkit within Visual Studio Code, which has lots of the playground's features. So it has the playground, the model compatibility, the model choice, and evaluations built into it. So it makes it very easy for you to start developing from both a spec-driven perspective using Copilot, or from like a vibe coding perspective using Copilot, or writing pure native code. So I think that's where we are today.
Got it. And I couldn't agree with you more, especially given that Microsoft is one of the only companies that has that full platform integration when we're thinking about models all the way to the different layers of intelligence plus tools and hosting on Foundry. Moving forward, this is where we'll begin to start to talk about the different agentic patterns that we're seeing across a spectrum of agent solutions that we have. Specifically, I think that rather than treating every agent as a repeatable kind of one-off, goes exactly what Talise says. We can start to kind of recognize the different common patterns that show up again and again, and try to figure out for single agents that are more complex, or do we need different tool use agents when we're thinking about these multi-agentic systems? Specifically, I'd say that the biggest area, and I would love to hear your insights on this as well, Lee, but the biggest area of transformation that we've seen is really in that single agent to multi-agent systems. Specifically, what I mean by this is earlier in the series, we had talked about kind of that low code to pro code, and then more advanced and complex single agents. But now you can kind of see, in exactly piggybacking off of what Lee had mentioned previously around just the diversity of opportunity that we have for different technologies, and again, the tools and models that exist to make these agents orchestration really powerful.
Yeah,
Lee?
definitely. So I think, this is, again, this is new technology. So there might be a lot of people on this call going, oh my gosh, what does this mean? So, a year ago, we didn't really have agents. We were talking to Chat GPT. We were giving it a prompt and it was giving us an output, and it was an LLM in the middle. Lots of models have come out since that, Claude, etc., and people are now using those. So there's still a lot of people in the no agent camp, just having that chat interface. We then moved to that single agent, and the real issue here around single agent was you're asking an agent to do everything, and an agent's not really an expert at everything. And do you really want the agent to have full control? And again, there's lots of press today around, OpenClaw and how much access it has, and it is multi-agent, but you could run it as a single agent as well.
Mm-hmm.
So that was one of the big issues around single agents was, you're asking an agent to do something, and what you want it to do is a very clear defined role and have very clear defined responsibilities. And this is where multi-agent systems are really taken off, because what the whole intent is that you're developing agents. So you're becoming a manager. As a developer, you're now a manager of a multi-agent system, and each of those agents is a specialist in their own right, and they might access different models. They might access small language models or large language models or both types of models, and they do a specific task, and you can start to create security and isolation boundaries around those so that your systems become more secure. Your output is about groundedness, relevance, and coherence. So that's the key goal is, and again, you want that high quality output. So that's why we're moving to multi-agent based systems.
Lee, I'm curious to know a little bit more for either within your own testing and or within teams, customers, users that you've interacted with. What do you feel like has been one of the, I'm not say biggest, but more common obstacles you've seen for people or teams who are trying to go from a single agent type of system to a multi-agent type of system?
Yeah, it's a great question. So again, it really comes down to that specification-led development. What is the intent of the actual tool you're trying to do? And I've got some demos which sort of try and demonstrate this in operation. So I think it's really about creating demarcation around specific roles and responsibilities and creating a workflow. So, it's back to the old UML mapping and creating, Visio diagrams of what are the tasks we want to do? How do we delegate and separate each of those tasks to become a self-supported agent, and then have that orchestration, the pattern of the agent orchestration to manage those agents. And we're going to talk about the different patterns, both in an agent frame, both in agents and in agent and multi-agent orchestration.
Awesome. And I think that is a perfect segue into this next slide, which goes over tool calling, basically. Another agentic pattern where you can start to develop that deeper sense of, do I have the right level of understanding of what my agent is doing? How has tool calling evolved from, I think you mentioned it earlier, Lee, actually, beforehand, a year ago, 2 years ago, it was a very binary input-output kind of response for a lot of the chat experiences. Versus now with agents, it is not only moved and evolved beyond zeros and ones input-output, but it can take action for you. It can reason against the different actions that it's taking for you. And with tool calling, I feel like this is an area that has also iterated and evolved exponentially. The tools are more advanced, and the way that agents leverage tools has also changed, I believe.
Yeah, and I think, it's a really interesting one. So like in this example, you want something to be done. So imagine a tool is like being a calculator function, or it's something which guides the users to input some form of data, which then does something. Now, tooling's great, but we've now moved on to MCP as well. So what we're seeing is lots of tooling is now being replicated with MCP because it adds that extra layer of security. So again, this is a pattern which is there. It'll probably be a pattern that adapts and changes. But again, you've got to think about, it's a great tool, but could I have an MCP server replacing that tooling functionality?
Got it. And I feel like the agentic patterns we're calling about, when we're talking about tool calling, one of the other things that I'd love to get your insight on, Lee, is just how should developers think about and start assessing the tool calling at a larger scale? to your point, they can do more things now. We have to kind of look at it from also the agentic layer. So even in this example, how do developers approach this when trying to have that clear delineation around roles and responsibilities for the agents?
Yes, I think it's not just roles and responsibilities, but it goes back to the model. So does the model support tooling to start off with and function calling? So if the model doesn't support it, it's not going to work. So again, it's like picking the right model and then also understanding like what do you want to do. So in this case where we've got the React loop, what we're looking at doing is like using different tools to check the status. So it's like looking at the image, it's understanding what is on the image in terms of the receipt, looking at the transaction history, then looking at how much has actually been paid. So what's outstanding, or what needs to be credited, or what needs to be refunded, or does somebody need change, or have the underpaid or overpaid? So we're looking at different ways of building agents, really based on business process. So we're actually going back, very much to business process mapping to then build agents and tooling that support that business mapping, if that makes sense.
No, that makes complete sense, especially where I think this side definitely captures where agents start to feel actually intelligent. Not because they're necessarily smarter than a human, but because they can also autonomously navigate a decision tree like this that would take a human multiple different steps and context switches to work through. But to your point, if set up correctly, this is how they iterate a lot quicker.
Yeah.
And then we have memory. I know that memory is basically what makes an agent feel coherent across time, rather than that goldfish brain kind of feeling that I think sometimes agents can get. And I said there's two types of memory: the short term of like what's happening right now. It gives you the access to steps in the current loop for a different kind of iteration, as the shared state context, the conversation history in this session, all lives in the thread. For long-term memory, where it shows what the agent knows across different sessions and has access to the steps and info in the long-running conversations, I think that is, how do I say? They're both drawing from the same memory store. And this is what really feels like unlocks that niche agentic user experience.
Yeah, this is, long-term memory is where you're going to create the value. So, good examples like customer transactions. So the ability for the agents to remember the customer ID number, and then also recall from that customer ID number all the associated product orders, inventory, etc. that user has had, because the output will be so much richer in terms of the interaction. It has that understanding. It's like when you speak to someone who they know your preferences. So I think that's the big change at the moment is models and services are now moving to long-term memory. And the Responses API from OpenAI is really helping to unlock this for developers. So again, I think that's going to be the big change. But again, longer-term memory, bigger context windows. That's the easiest way of thinking about it. It's going to remember more.
Oh my goodness, could not have said it better myself. Before we move to the next slide, Lee, though, I'm curious on your insights, just because I know we have viewers at all stages of their journey and interacting with agents, building, deploying agents. So for our viewers and developers out there, how would you think about, or I guess, what would your advice be on the approach when these individuals are thinking about memory for their agents? Given that they have the short-term versus long-term options, like how should they start to think about the truncation strategy to use?
It's a good question. So I think, you've got to think about, again, going back to what is the business intent of the solution? What do you want the agent to know? There might be cases where, think of like medical details. You want some form of long-term memory, but you only want long-term memory with the intent of that person you're dealing with. So, you want to be able to have, so it really comes down to like security.
Yeah.
What's the security? How much access do you want to give to the agent? How much information do you want to pass back to the end user? And so, so there's various different things. So I would say definitely look at long-term memory, because it's going to give you the maximum value to the outcomes in terms of the agent response.
Oh, well said. With that, we are also talking about the flow control for this next, and I think last agentic pattern that we have. And specifically, when I think we think about the human in the loop element. So even like in a highly autonomous agent or a complex agent, multi-agent orchestration, you're going to need to have the safety valves, exactly what you said. We're going to need to have to make sure that we are considering security, which will impact how we think about the overall agent deployment, how they work with us. But this slide shows the payment agent again. And you can see that the two places where a human steps in is in the user review checkpoint that decides whether to proceed or approve the payment and the ability to escalate. And then on the left-hand side, we have the looping termination. So, when does the agent stop, the max number of iterations, the human step to exit the different loop. So the architecture message, right, is like fully autonomous isn't always right. The best
no, definitely not. No. And I've got a demo to show the reasons why it's not right. But yeah, so fully autonomous is not right. So again, think about this from and I'll show this in the demo later, but it's really about what are the business processes, what are the validations. So if you're like dealing with like legal documents, what's the validation? Is the terminology that needs to be changed if you're sending it to a different country? What is that validation check that has happened? So yeah, flow controls, I think, are becoming more and more important, 100%. And I think you should be considering how flow controls are implemented in your systems, especially if you've got that customer engagement and, the quality of what is being received and the quality of what's being said. And again, I've got a good demo to sort of show where flow controls can be used.
Perfect. Okay, awesome. With that, I will transition a little bit to go talk about our, what's it called? Our larger different agent systems, how we approach that. But before that, I just want to make sure there's no comments we're missing from the viewers. Awesome. Thank you for joining today. Great to see people tuning in from South Africa, from London.
Yeah, India, South Africa. So it's very late their evening. So, I don't know what time it is in India now. I think it's very, very late. So huge thank you. And again, with South Africa.
No, very much so, especially what's it called? Yeah, given the timing and everything. And then so our next couple slides, I wanted to go through these, and Lee, please feel free to chime in and where you think needed. But we're looking at the different kind of design patterns as well. And I know that we had a lot of questions in our previous episode around what do these different multi-agent systems actually look like? What are the different types? So I want to spend a couple minutes going over the different things that go in here. And if you have questions, please leave in the comment section. After this, I'll pass it to Lee for that demo that he mentioned. But we had touched on this in a different episode in the series, so we won't drain or go deep dive into RAG at large, but retrieval augmented generation as an agent or implemented within your orchestration is going to be the knowledge graph, the search power to make sure that your agents are producing high quality work with high quality answers. And when we think about how powerful RAG tools can be for tackling these complex questions, it really opens up what you can do with agents. I think this process definitely involves multiple iterations. A human in the loop, like we discussed, is definitely the first step of what we should be looking at for deploying these types of orchestrations. But that human in the loop for the agent flow is going to be the final piece to ensure that we have accurate information and that the information that's being provided by the agents is as comprehensive as possible. The next kind of agent that we have is a code generation agent. I think this is fairly straightforward when we talk about the different types of
Copilot.
Exactly.
Yeah, Copilot.
Just like Lee said, we have Copilot for this, but this is going to be your go-to code generation agent in addition to your deep research or your RAG search agent. Lee, anything else to add on these two before we get into like our first?
No, I think the key thing is always if you're starting with anything to do with agents, always start with like the funnel idea. So prompt engineering at the very top, extremely cheap, very easy to do. You're going to need a system prompt, well-crafted system prompt, agent rules, boundaries, and guidelines. RAG, you're adding data to your data. You're adding additional data to your model, basically. So you're just making the model better. garbage in equals garbage out. So if you haven't got quality data, don't rag it because you're not going to get good answers. And then at the very bottom, you've got fine tuning if you want to build a customized model. If you want to build a customized model, great, but it's going to be very expensive. So always start with prompt engineering.
Agreed. Perfect. So multi-agent systems. When we think about more complex agents, it really kind of goes back to everything that we had mentioned, the type of problem that you're solving for and the business parameters or limits around what you can do. So really taking that complex problem and decomposing it to smaller, more manageable, digestible chunks, each addressed by specific specialized agents or domain efficient agents. It kind of creates like a little microservice, essentially. These agents are going to work together in a coordinated manner within a specific workflow, all the different kind of workflows that we just previously talked about. And the idea is to have them efficiently solve this problem in a way that is, when we say efficiently, better, cheaper, faster than what a human could do. When we talk about the critical design elements that are included for this, adaptive planning within scope of existing scoped agents is super, super important, making sure that they can handle ambiguity by, I guess, and Lee, correct me if I'm wrong, but I think this comes into what you talked about for making sure that you have the right prompt engineering, making sure that when you're thinking about putting together your system of agents, in addition to RAG, code generation, or whatever else you might need, that you have the right foundation of agents to make sure that the overall system works as intended.
Yep. Yeah, 100%. Again, your system instructions, so your agent instructions is okay.
Yep. Okay, perfect. And then this will lead us into also what we talk about for multi-domain agents. Before I move into that, though, Lee, would be curious to hear a little bit more from you that when, I guess, how should I act? When a team decides that they actually do need a multi-agent system, because I think that's part of what we're also covering in this episode of like, not only what are they, what are the different components, but how to decide when you actually might need these different areas. What would you say maybe at this point is like the tell for a developer or a team as they evaluate multi-agent systems? Is there a specific moment in the design process where you know that you kind of need to decompose different things or make sure things are better aligned into multi-agent versus one?
Yes, I think it's, number one is if there's a flow required or human intervention required, you're a multi-agent system, number one. So that's like the first check. Is there some form of flow required? Second one is like that, we talked about before, it's like demarcation of roles and responsibilities. So, imagine an issue where you want to do like a review, a writer and a publisher. So, I want to create a blog. So to create a blog, I need a researcher agent. I want an agent to go out and do some research. I then want a writer agent to take the research and write the content. And then I would like a reviewer agent to do a review on the content I've written. Now that's like a basic multi-agent. You just don't want to go create me a blog, with a single agent. It's like create me a blog, and it's like does it, and it's like yeah, that's great, because you're as a human in that review stage. So again, that's a great example of where you should have a multi-agent solution. Now your level of multi-agent solutions can progress as much as you like. There's no limit to the number of agents. But if you do have an agent and it fails, what happens in your process? So I think this is another consideration of like, what is that failure point? If an agent fails, you end up with no output. So your customers sat on their chatbot, waiting for a response, and nothing's coming. So that's something to think about. It's like, what happens if something fails? What's that workflow process?
Especially as we kind of talk about these different multi-agent systems and also the multi-domain agent systems, having, and again, Lee has a demo for some of this stuff that we'll talk about a little bit more in depth, but this all goes back to really that level of telemetry, making sure that we can track where different agents might be falling off or where things are breaking, because if you don't know, exactly like Lee said, you could be sitting on stale information, the wrong information, or just zero to no outputs. And I guess the transition here would be, when we're thinking about the critical design elements, we want to make sure that we have, as shown here, the right agents, right agents and right agent capabilities. And in this image, you can see that the agents are orchestrated by an agent runner, and that's to help scale across multiple domains while appearing as kind of a single agent to users. So when we think about the scalable agent runner able to manage 10x, maybe like 100x of the different kind of agents that they can have, the ability to manage domain switching with the proper memory management, proper context management is critical. So to avoid any kind of these issues to avoid any issues that might come up with multi-domain agent systems, especially if they're appearing as one agent, the right architecture from the agent pool to making sure that all the agents are orchestrated through the runner layer is top of mind. And this is one of the #1 enterprise use case stories that we've been seeing. But Lee, would love to also get your input on, when we're thinking about how to avoid the single interceptor kind of problem. I think that's like a really interesting constraint. I don't know if you've seen this or run into it, but I feel like it's becoming more prevalent the more that agent systems and multi-domain systems are being used in practice. What are your thoughts on that, or what breaks when you don't solve for it?
Yeah, it's definitely true. And there's a really interesting question that sort of relates to this that Troy Vekashuka, I think is how you pronounce it, is added to the chat. So, they're asking about insight into how agent distribution across users is structured in an organization. And this is really like a multi-agent domain system in some cases, depending on the organization, what you want each of the agents to do. So, really, it can seem really challenging for SMEs. And I think for SMEs, it's really looking at, number one, what access are you providing to your users in terms of that agent gateway? So like if we look at a multi-domain agent problem, it could be a multi-agent problem related to like dynamic CRM. So in dynamic CRM, there's a number of different agents. Yeah. I can't remember the number. I think it's 19 agents in Dynamics, Aaron. I can't remember off the top of my head. But, you might want to do a multi-domain agent system based on a Dynamics process. So it could be like accounts receivable or invoice payments. So again, you've got to think about, what's the business problem? What are those multi-domain agent systems? Because it might go from like Dynamics to SAP to procurement to deliveries. You might have like an API or an agent talking to like your delivery company. So again, I think it's about, how do you plan out those business models? And again, coming back to effectiveness, what is this replacing? You're not just building an agent. It's like, is it going to make your organization more effective? Is it going to reduce, the cost in terms of staff? Is it going to improve the NSAT of the customer experience? Is it going to make you more profitable or have that market opportunity? So I think it's really looking at those different factors, and then the platform which you're going to provide to your teams, whether it's internal or external, of the access method. Is it going to be a Teams extension or a Teams agent, or is it going to be a web agent, or is it going to be an application solution?
No, that is a great point, especially actually the perfect segue as we kind of think about the next area for common AI agent use cases. I'll go through this section fairly quick, and then I'll turn it over to Lee so we can look at some more of the actual setups and demos. But I think these slides are important because when we think about what is needed, how developers should think about choosing and assessing for their orchestration systems, AI agents are already making significant strides across different various industries that we have. Like Lee mentioned, there's a couple different things that are happening internally for agents. There are different projects that are happening with customers where they're building travel booking, employee engagement agents, anything to Lee's point where they could assess how do we reduce the amount of human input, how do we make more profit, and or how do we streamline the amount of time and capital going into certain areas. So this is just an overview of kind of what that looks like in the industry, how it's being assessed over a wide different categories for healthcare, energy, manufacturing, travel, and retail. Anything else on this that you want to add, Lee, before we get into the Microsoft?
No, I think these are just, good use cases. And I think,
Yeah.
there's pretty much agents being used in every type of role now. So, I think, so I think that they're good examples.
Perfect. Okay, getting into Microsoft Agent Framework. We had covered this in depth in our last Azure Decoded series. So
it's an orchestration tool. It's to orchestrate your agents. That's what you need to know. If you want to have a multi-agent environment, Microsoft Agent Framework is the tool to orchestrate your agents from Microsoft, from LangChain, from LangGraph, Crew AI. It's a single platform. That's the key thing.
Everything.
And it's open source,
which is even better. Open source engine for building and orchestrating all that you need. I'll go through these slides, Lee, but I think we'll probably get to the demo piece. So
so we'll just quickly talk about like the different patterns, and then we don't need to go into it in depth. And then
perfect. Anything that you want to talk through on these upcoming ones?
No, so I think, the key things we just said, Microsoft Agent Framework, completely open source. It's an orchestration tool for any type of agent service. As you can see, it supports pretty much all these different areas.
Yep. It also has the functionality to connect into a bunch of different MCPs. The open ecosystem here, I think, for a platform is also what's key. Being able to offer the integration, tools, and extensibility that other platforms don't always have as wide of. And then we also have our memory and conversation state. Again, very similar to what we covered at a high level earlier. This is just a deeper look into kind of
just saying it supports it. It supports it in depth. So it supports memory and flow control, which are the key things that we talked about.
Yep, these different things that we had covered earlier. And then same thing for observability, telemetry, when we think about the logging and tracing of all agents at the enterprise level, middle and guardrails, again, so you have that security at all different levels. And then the different agent systems within the agent framework, this is directly what we were talking about for orchestration, the different levels of orchestration, and then we have multi-domain specific orchestrations that also happen. This is just a high-level overview of some of the patterns that we're seeing come out, and the ones that are usually the more popular. I know that we did a poll earlier in the chat, and it looked like we had 30% of you guys click for delegation patterns. We had collaboration patterns, and then also some debate ones. So it's good to see that there is some alignment from what you guys are seeing and using, and in addition to what is supported across the platform. Lee, did you want to go into a deep dive of any of these specific patterns that we have?
Yeah, so we basically just highlighted here each of the different agent patterns, but I've got a really nice demo that I'm going to make available to everyone to sort of show this in more detail. So, sequential, it's a step-by-step approach. One agent passes to another agent. Very, very simplistic. And then we have the concurrent pattern, which is about, single agent looking at different agents, so supporting different agents to run the task. So each agent is running concurrently to do their piece of work, and then they pass it back to address the final solution. We have a group pattern. So again, it's groups of agents working together to then, pass the details back for formulation. We have a handoff pattern, which is basically handing off the orchestration to other agents and saying, like, you tell me when you completed and move on to the next task. And then we have the final one, Magentic pattern, which is looking at, managers. So the ability to agents to become self-management as such. So communicating directly as specialist agents and gathering the right information.
And before we move on to the incredible demos that we have, I'll leave the group here with, this is my favorite pattern. I know that in our last Azure Decoded series, we had talked about the handoff, but I've been messing with I've been using the Magentic pattern a lot with my own agents that I work with at home and mess around with, and also how we think about it in our work here at Microsoft. So this has been super interesting to me. Definitely leave a comment if you guys have any questions on this, or if you guys are using different patterns. I'd love to see more. With that, Lee, anything else before we get into the demo?
No, I think we can move over to the demo. I think, yeah. So first of all, I've got this demo. So if you want to scan this QR code, this will go to my repo, so you can actually, get the code, etc., to actually start to work with this demo. So if you want to share my screen, and then I can sort of talk through what these demos are. So the first demo I have is what we call the agentic pattern. So what I wanted to try and do was everything we just talked about a minute ago in terms of those patterns is put this into a real demo so that you can actually see how these agents work. So this repo literally takes you through all the different agent patterns and then has a solution and a sample which will show you how these agents are actually orchestrating. So please do, download this. Again, I've got screenshots, I've got full setup instructions of how to use it. So let's get into the demo itself. So the demo is actually a web app. So you install it, you can configure it. It will actually use either Microsoft Foundry local. So if you've got a local LLM, so again, it's going to be free to use because it's using Microsoft Foundry local, which is installed on your machine, or you can use Microsoft Foundry Cloud. Of course, because we're looking at multi-agent, larger models, much faster response. When we talk about multi-agent, it's using the Microsoft Agent Framework. And what I've done is created a number of different demos which exactly take you through each of those different patterns. And again, there's a prompt which can be used, or you can add your own prompt, which literally says, what we want this to do. So this is a sequential, make a check, a PR review. So it's looking at a PR in terms of a GitHub repo, and it's going to calculate the number of different correctness changes. So if I just click on this and show it running, you can see what the prompt is at the top. And you can see visually, so there's a graph to actually show you what the agents are. We also then have a live stream of the agent interactions. And this is really important when you start to consider this multi-agent framework. We have a timeline of which agents are doing what. So, we can see the orchestrator started, it's handed off to the worker agent. And if we click on each of these, we can see the messages that are being passed between the agents as the process goes through. And then we've got the output from the actual final agent of what, the completion of our prompt. So what the question we asked, how is it going to answer? You can see the different chats from the different agents as the reason. And then we've got the reviewer. So, it's a great example of how we can take these overall architectures and then visually show them how they work. So that's very, very simple. It was two agents talking to each other. As we move through, we've got different ones. So we've got like the handoff. And again, we've got a triage, we've got billing, we've got technical support. So this is a technical support agent. It's basically asking the question, I was charged twice for my subscription last month. I can't access the admin dashboard. Can you help? And you can see I've just been showing you this, it's done it. So the triage agent says, it wants to understand billing and it acknowledges that we're very sorry. Then it passes it over and it says, yeah, I'm going to pass this now to the billing agent. So again, this is about that the demarcation of roles and responsibilities. It's a great example of triage is there to help someone. So very, very fast, instant response. I'm here to help you. I'm going to pass it now to billing. The billing agent then takes it on. It's like, oh yeah, confirms it back. So it's got a very good persona saying that they're very sorry. You've been double charged. I'm now going to look at this issue. It then goes off and looks at the issue and passes it to the support technician. So you've got this flow of the agents passing the messages between themselves. So again, individual roles and responsibilities, and then the final outcome to the end user of that real message. So again, a great example of how these agents are communicating and the reason to have individual agents doing these tasks. Now, if we move on to a more difficult or a more complex one, we've got the swarm auditor message. So this one really looks at three generator brainstorms in parallel. So these are using the concurrent builder. So we have generator A, generator B, generator C. We have an auditor and a selector, and then we have our prompts. It's saying I'm a mid-size SaaS company wants to reduce cloud infrastructure costs by 40% while maintaining 99% uptime and improving developer velocity. What should we do? So this is like a business analyst agent. So what we're doing here is we're using this handoff agent to basically use the generators to come up with some ideas. So generator A is bold and ambitious. Generator B is practical, so it's going to be like very, very stable. Generator C is very safe, so it's going to be very reserved. And then we've got our selector. So let's see what these come back with. So here's our proposal. So the orchestrator passes off to the agents, and the agents work on their own until they get an answer. So you can see each of them coming back with an answer.
They're so fast.
Yeah, it's really fast, isn't it? It's really fast. And this is actually using the Microsoft Model Router. So the Foundry model I'm using is Model Router. So each of these agents could be potentially using a different model, which is really nice. So then, you know, I have the output, which basically says like, you know, generator C. So generator C was safe. So it's saying conduct a comprehensive detailed audit. Very safe. Identify underused or idle assets. Based on the findings, implement strict resource scheduling. So definitely C was very, very strict. Operator B, implement a right sizing strategy by conducting a detailed audit. So it's the same, but not as safe. Looking at cost auto scaling. And then if we look at A, let's see what A said. So A was like, develop an AI-powered self-optimizing cloud orchestration platform. Let's go for it. You know, so we've got this, you know, very mixed response from these agents. And then the auditor will look at these and assess which one it feels is the most appropriate. And it ranks them all and gives them a score. So it's quite neat. So then as a business decision maker, you can say, yeah, okay, I quite like the idea of this, quite like the idea of that. So it's saying proposal C, cautious and straightforward, but lower impact, reflecting a conservative approach for cost savings. So, you know, it's a great way of showing how these agents work. Now, the final demo is looking at the Magentic looking at the Magentic pattern. And this is using a Magentic manager, a researcher agent, a strategist agent, and then a critiquing agent. So this is looking at the feasibility of adopting an AI model like Foundry Local for a mid-sized enterprise, and current state of technology, a recommended adoption strategy, and the top risks to watch out for. So again, you can change these prompts. These are just base prompts I put in, but this is all editable. You can just do it yourself and run it. So let's see what this comes up with. So again, this is live, so I'm going to wait for it.
No, I love it.
But again, you know, this is a great way of visually seeing and then understanding that handover process, because the timeline is there and you can actually see the JSON messages that are being passed between each of these agents. And again, you know, one of the things that you should be looking from a valuation perspective is the time to first token. You know, that's, you know, that when someone is interacting with your agent, you know, you don't want to see that spinning wheel, because that spinning wheel means people will leave, whereas you want that instant response. So what you're trying to do is drive the latency of these responses as low as possible. And again, this is why things like Model Router become really key, because it can take a very simplistic question and go, right, I'm going to give that to GPT-4 Mini. I'm going to set this massive like research question and give it to GPT 5.2. I can take this question and give it to Anthropic. And again, you can mix your models. So again, you know, this is really interesting because it's come back now with all the different findings. And again, you know, you've got that complete flow of timing and messaging between each of the agents. So you can see the full handover process. And again, how these agents are working together. So it's not that sequential flow of the critic does it and then it doesn't do anything else. The strategist has handed it to the critic has analyzed it, it's passed it back to the strategist, it's then gone to the manager, it's then gone back to the researcher. And again, you can see that flow as it's passing the task between each other. You know, it's an agent, it's doing an individual role. So please do have a play with this. I hope you do find it useful, but it was just a great way of being able to visualize how these agents are communicating with each other and that communication process, and also how they're handling these messages, because again, this allows you to refine your system prompts. And again, it's a VS Code solution. So if you're interested in looking at any of this, you know, I'll just quickly go over to the agents, and you can see the agents. So like, you know, each of the agents is separately. So this is a handoff support. You got your Swarm, you got your Magentic, so the Magentic one we're just looking at. And if you look at the actual agents, these are the instructions. So as I was talking about, these are the ground rules. These are our system messages that we're passing to the agent. So again, you can refine these and change these to be more appropriate to your organizations. But these are the ground rules that the agents need to conform to. And they're written in plain English. That's the key thing about working with agent-based systems, is keep this as simple as possible. Do you want me to jump straight into the next demo, Aaron?
Yes, let's just jump right in with our last 10 minutes that we have.
Cool. Like, we've got another slide. So again, I've got another repo. So if you want to just quickly show me the slide and then the QR code on it.
Yes, let me make sure this is the updated version for everybody. Yep. And then were we able to flash up that second QR code for everybody?
Yeah, if you can just swap the screen down and just turn back to the slides. Thanks.
Perfect.
Cool. So this is the second demo. So again, if you want to take a screenshot of this, and this is a multi-agent system. So this is an actual solution, which is using Microsoft Agent Framework, and it's using the new Azure Agent Services hosted agent. So this is where we can take our agents that have been built. So we've got a number of different agents. We're then going to wrap those agents in a container and then host those agents as a single agent in the Microsoft Agent Service hosted agent service. So then we call in our hosted agent, which is very, very nice. So again, if you want to switch back to my screen. So this is a repo. It's called On-Call Copilot Multi-Agent. And this repo is basically a solution. So it's a NOC. It's an operations center dashboard management tool for engineers looking at systems problems. So we're taking JSON system events into our service. And if anybody's looked at JSON from any of our App Insights or any reporting systems, it's an absolute nightmare. We then want to create these observability views based on different types of users. So we're going to look at number one, understand the root cause or the triage of the issue, have a summary and a status, a communications plan that can be issued out over Teams or Slack. And then we want an update in terms of the status of the problem. So again, this is a full solution with a web front end. So this is our web front end. We've got 3 demos and 5 service incidents. As I said, when we look at the actual input from any monitoring system, it's in a JSON string. So again, if you received an email with this, how long would it take you to work it out? So it's saying there's an incident, you've got a title of an APA gateway, you've got a severity issue of 3, and then an output. So what I can do is I can quickly run this analysis through my multi-agent solution, and it's using, as I said, it's using the hosted agent service. And this is now being processed by those multi-agents, and it's going to come back with each of these responses. So this again is live. So, we'll just have to wait for it to process. So this is currently going off and hitting these gateways.
And is there anything consistent that you've been seeing on your end, Lee, as you build out some of these tests and these different repos, especially with these multi-agent systems?
In what way, Aaron? Sorry.
I don't know, just in a way that maybe has surprised you, because I know that a lot of the frameworks, everything is evolving so rapidly. Some of the stuff that we're discussing today didn't exist 6 months, a year ago.
Yes, I think it's rapidly changing. I think MCP is becoming this real opportunity piece. And I'm sorry for this demo taking so long. So the key thing here is with the comms aspect here. So this is basically at the moment providing a Slack update. So I've built this to utilize MCP. So again, if you do have Slack in your organization or Teams in your organization, you can actually then have the agent post the content directly as a Slack issue. So again, this is really where we're changing how the agents become much more scalable and effective in terms of that communication process. Like before, it wasn't just we had a knowledge, we had an FAQ bot on our website, which basically gave you an answer. It's now how is this making business decisions or intent to users to make a decision? That's good. Failed. That failed. That was a bad demo. Let's try this one.
It's not a real live demo if we don't run it.
Not a real live demo unless it fails. It's like, oh gosh. Great.
Oh my goodness.
This was working a minute ago. While that's loading, okay, what we'll do is I'll show this other demo, and this is an example of that whole flow control that we talked about earlier. So what I wanted to try and do was give you a demo where we've got a business process task. So these tasks are like sending an NDA to 12 partners, fixing a recipient that can't sign. So this is a legal company who's sending out agreements. And then we've got a number of different agents. We have an orchestrator, an intent, a policy compliance, a document data, delivery recipient, and a comms. So in this case, I want to send a mutual oh God, that was fast. I want to send a mutual NDA. It's like they're too slow, too fast. I want to send a mutual NDA to 12 partners, okay? And I want ID verification for each. So first of all, the intent UX agent did its thing, and it said, I want to send an NDA. Great, yes, so I understand what you want to do. It's going to use a standard approval template, and it's going to send it to 12 external partners in the list attached. The deadline of the date for it to send, and then what the users need. So they need to verify. The document data then produces the NDA. So it's said, I've got a template. I know the 12 records out from the CRM. I've auto-populated it. But two of the people are missing details. And Exhibit A is also attached. So then the policy compliance agent says, oh, right, okay, let me check it from policy. And you can see this company is in Japan. So it's saying like our current NDA isn't valid in Japan. So I can't do this unless we process an amendment. And this company's in Germany. It needs GDPR amendment as well. So then it goes to a human approval. So this is that flow control, because the agents have worked out what they need and what is like in policy and out of policy. Now it's a human who has to review this. So it's saying like, I've got two recipients. And if you watch this, when I click it, you'll see the handover of these agents. So you can see the green ones are the ones that have been run, and the orchestrator's still holding the job until I say, let's review the flagged, or if I click approve and send. So I'm going to click approve and send and see what it does. So you can see delivery recipient, then the comm status kicks in. So the delivery recipient has said, yeah, it's sent 12 NDAs, it's verified the idea, and it's added the 2 regional amendments and the deadline for when it needs to be, and then the tracked example I can link to. So that was a human in the loop, making sure I was happy with that. Oh yeah, it was flagged, it was going to be addressed. If it wasn't going to be addressed, I could have gone in and changed it. And then I've got the full audit trail, exactly like I had in my other demo, of the different agents passing the work to each other, which is really nice. So again, this is a great example of that flow control of agents. So let's just go back.
To see like end to end.
It's done it while we're talking, which is great. 77 seconds it took, which isn't so. Again, this is like one of the biggest frustrations I hear from lots of customers of like, oh, that took 77 seconds to do that. It took a JSON schema, which is an absolute nightmare to understand. Right? It's anybody like can see and read this. It's like it's a Redis cluster, unresponsive with an error number, and it's like something's gone wrong somewhere, replica failing, and then it's created these root cause analysis, which are human interpretable. So it's like I'm on a support desk. I can go, okay, root cause analysis. Redis master became unresponsive. Brilliant. Loading a sentinel failover. Confidence scores 66%. I've got actions. So like validate the Redis. So I can go in, start doing this as a technical person, run the Sentinel inspection, verify the connectivity, assess and address the problem. So as a support desk, and say, oh, right, okay, this is what I need to do now. So like the support triage person is running this. They've even got a run book. What do I need to do? So that's like the support desk person. Then you have a summary of the incident. So this is like what happened, what is done. This could like go to a GitHub PR. It could then post the status to a service desk. So people check the status. It says what the status is. And again, I've got all this information. I then have a comms that goes out to all the communication channels with the incident ID, with the numbers, the issues, the details. And then I've got this auditable timeline of everything that happened. So I can see when the service failed, where we currently are now. So like we're only 2 minutes in, if you think about it in that way. And we've got all this information, and the end users have all this information, which is like phenomenal, you know, from just having this single app insights JSON import to all this management detail is phenomenal. You know, I think that this is like one of the key things that goes, oh my God, this is where I can see the real value of a multi-agent system.
Yeah, no, this
So I
is
hope
incredible.
that's useful. And again, these are all open source. They're on my GitHub. If you want to play with them, you can adapt them. They've got base level prompts and systems instructions, but feel free to have a play and change and adapt. So that's what they're built for. So that's me in terms of demos. And I'm sorry we're running over on time.
Not at all. Thank you so much for going through that. That was super helpful. Even kind of looking at everything, despite how like in it I am, I feel like I'm learning new stuff as well. So I appreciate it. Thank you to our viewers, to all of the wonderful staff behind the scene that are able to make this happen. On screen, you'll see a bunch of new free resources that you can go to watch more, learn more, actually get some hands-on keys if you want to dabble in any of the examples that we provided for us today. We'll also make sure to share out the links so you guys have it if you weren't able to get a picture of the demo. But
yeah,
thank you,
Lee,
so
in the
much.
Chat as well. They're all
Incredible.
They're on my personal repo, so feel free to play.
You'll be able to go through Lee's repo and grab those stuff. But thank you, Lee, so much for coming on today and joining me for this episode. It was incredible to have you.
And again, if you have any more questions, we have the Discord, we have all these amazing resources. So yeah, please do learn them. Please give us feedback. You know, we want to try and demonstrate why multi-agent and agent solutions are so good.
Yes, exactly that. Yeah, and thank you again for viewers who have tuned in to the series. We have another episode coming up in 2 weeks, so appreciate it. Make sure to interact with all of our Learn content, the resources. Go and look at all the repos on Lee's GitHub. And until next time, we will be back with you then. Thank you, guys.
Thanks, everyone.
Bye, everybody.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.